Yeah, you can start.
Okay. Then welcome everyone, and good morning for our Brazilian community, and good evening, good afternoon, Patricia, in your time, and welcome for the first international keynote in this Brazilian Symposium on Software Engineering. It's a pleasure to have you here, Patricia. Thank you very much for accepting our invitation. This talk is very, very interesting for the community, I'm sure. Then I would like to introduce Patricia very shortly. Patricia is a professor at Vrije Universiteit Amsterdam, VU. Yeah, so it's Dutch. I don't know how to pronounce it in Dutch, I'm sorry. I think it's VU University, VU Amsterdam in the Netherlands. And she leads a software and sustainability research group in the computer science department at this university. And her main research topics are software architecture, software quality assessment, and software sustainability. And she's very, very known in the community of software architecture. She's very active there, yeah. And we worked together in the beginning of this year in ICSA. It's a very pleasure for me. And she has served as chair, member of steering committee and the program committee in many international and big conferences in the software architecture area, like ICSA or EXA. And she also leads ICT4S, International Conference on Information and Communication Technologies for Sustainability. It's a very interesting conference in the area of sustainability. And she has a number of publications in high-ranked vehicle. Then, thank you very much, Patricia, for accepting our invitation to be here. It's a pleasure for me and for the Brazilian community of software engineering. Okay, then feel free to continue your presentation, okay?
Thank you, Elisa. You are too kind. and to Christina Marcelo for inviting me, and to you all to be very awake, I hope, for this talk. I know this is the kickstart of your day, probably, so that is a little bit of a responsibility. So I hope that you will find my talk interesting. Also, we discussed before, so it would be great if you have any questions during also my talk, to simply raise your hand or interrupt me, and I ask Elisa if she kindly can monitor also the chat, because I don't know if I can manage everything, but feel free just to stop me whenever you have comments or questions or anything that is unclear. Here you see also the QR code. I know that well, the slides will be made available afterwards, but if you want to just download the browse, and feel free to do so. Said that, let me just start. So in this talk, I would like to leave at least one good idea behind for everybody, or maybe one starting ideas. And from my perspective, there are at least 3 takeaways that I would like to give you. The first one is that when we talk about sustainability in a digital society in general, and specifically for software, we think in terms of the positives very often. And we not necessarily always check that these positive effects are realized. So in this direction, software can help towards certain sustainability goals, but also they can hinder. And it's really important that we design for sustainability, which leads me to the second takeaway, that we make a lot of decisions throughout the software engineering process, but only by tracing the chain of decision throughout the phases, and by taking measures and evidence, we really are able to check if the target goals are achieved. So decision-making must be always informed. And this is valid in general, there is nothing new here, but especially for sustainability, if we focus only on the positives and we don't check, then we have maybe the belief that we are doing something good, and then maybe we are diverging instead. And the third aspect is more of a passion of mine, but also I think in in the digital society at large, the cloud industry, the data centers around the world are a very crucial case for software engineering as well. And in that respect, the takeaway is that data centers that support the cloud industry may be often claimed and actually be energy efficient, but not necessarily they deliver sustainable cloud. So cloud sustainability is different than energy efficiency of the data centers themselves. As a side thought, I would like everybody to think, to keep in mind the following questions. The fact that in the digital society, software is everywhere, but really in the research and in the practice we are busy with, which big one research or practical questions are we addressing with our research? So this is led by the reflection that there are different types of society, different types of realities, different degrees of freedoms in these societies, and different degrees also, different economic systems, societal systems. For whom are we developing our software-intensive solutions? And sometimes I have the impression that we are targeting too much the 20% of us and too little the 80% of us. Notwithstanding, all targets or situations are relevant, but we should keep in mind that we are doing research to improve our society in the shorter or longer term. And maybe each research is a tiny little bit contribution, which of course matters, but we should keep in mind, so what is our tiny contribution to the bigger picture? So I organized the talk in 3 parts along the 3 takeaways. So first of all, I would like to bring everybody on board on the notion of software sustainability. I was thinking, preparing the talk, that on the fact that if you look at most, if not all, publication in the field of the intersection between software and sustainability, most publications do not actually provide a definition, and many that go in that direction, they build upon the definition of sustainable development of the United Nations Brundtland Report, Our Common Future, which goes back to the 80s, which is actually a good starting point, but is not actually geared around software or software engineering. I think there are 2 aspects that are helping in the direction of a definition, but still are not are suboptimal. So I think that there is a lot of work still to be done in that direction. One aspect is the fact that we can talk about sustainability only over a certain period of time. So if you think about measuring the quality of a software product and then applying some optimization and then measuring again the improvement in terms of quality, maybe we improve in this cycle, but not necessarily the improvement is sustainable. Sustainable means only that it can be maintained at an acceptable, stable level of quality over time. So there are a lot of works that use the term sustainability, but actually they don't reflect or don't extend the achieved sustainability goal over time, which is negating actually the statement. The second aspect that is also at least equally relevant is the fact that sustainability is intrinsically interdisciplinary. So there are many different, what I call dimensions of focus that are already well established actually in the field of software engineering, etc. And the example I was making before, the quality of a software product, is typically in the dimension of the technical aspects that could eventually be relevant for a sustainability goal, but there are also other dimensions of focus. We are very comfortable with economic implications of software engineering, and the technical aspects, but we are less mature in terms of the societal impacts and as well as the environmental ones. So in my work specifically, these 4 dimensions of focus are investigated. So reflecting on this combination in a definition that diverges a little bit from or specializes better the Brundtland Report 1 on sustainable development, this is what I came up with, and it's recent. I mean, I was thinking about that last week, but this seems to be a little bit better in the right direction. So software sustainability for me is the preservation of the long-term use, but also the beneficial use of software. The long-term in terms of the timeline I mentioned before, so the second bullet here, and the beneficial use in terms of the different dimensions of focus, depending on what is relevant and what is important. And also the appropriate evolution of the software overall in a context that is in continuous change. And this is the third aspect that we have to consider when we assess the impact over time. So we know that the software that is used needs to change, and the reason is that the context, including the users and the related requirements, change as well. So all these 3 aspects, timeline, dimensions of focus, and contextual change, I think are equally important, and especially in the fact that in the digital society, the more digitalized we become, the more the context becomes equally important, as important as the systems themselves. So this picture represents a lot of notions that I'm sure you are already very comfortable with or knowledge about. On the right-hand side, the SDGs, the Sustainable Development Goals, that try to bring many different dimensions of focus in the different sectors of our society. The origin is more or less on the right-hand side, the triple P, in which we talk about the 3 big variables or dimensions: people, planet, and profit. Below, you see the 4 dimensions of sustainability we put forward in our work. But one or the other, they are all relevant. In the center, you have the notion of orders of impacts. It's go back to many years ago, even unrelated to ICT or software. So the order of impacts that are classified into direct, enabling, and systemic. To give you an example, we talk about direct impact. If we look at the technology as such, for instance, a server for hardware or a piece of software in case of software engineering. And then we look at the technology itself, and we see if that technology or the software is sustainable. Like, for instance, from a technical perspective, if it is maintainable, but also from environmental, if it is energy efficient. The enabling impact is then we look at the sustainability of the processes that a piece of software is supporting. For example, I might have cloud-based software or services that allow me to work from home or to give this guest lecture at the moment. And this means that, for instance, Zoom, in our case, not necessarily is technically or environmentally sustainable, but it supports a sustainable process of me being able to talk with you guys without traveling. So this is also important, and it is estimated to be the big chunk, actually, of sustainability we should focus upon, because having software influencing how the sustainability of the sector means that basically it influences how sustainable are the software that the processes that are supported. And the third aspect, the systemic, is when, thanks to influence in the different processes, we change the behavior of society in its interactions. So, for example, the fact that we are able to have blended conferences or hybrid conferences, like in this specific case, changes the way we do research or the way we interact and discuss about conferences or about research, sorry. And this may mean that also the research as such may be influenced. Maybe it's better, maybe it's worse, but depending on maybe the structure of education changes, or maybe the structure of research institutes change, with a ripple effect also on the type of knowledge we create, and then if this knowledge was necessary or not in society. So that we can go on and on about reflecting what are the chain of effects that can have systemic impacts. The last about the rebound effects. Rebound effects are typically effects that are unpredictable and that happen beyond our control or our plans. Typically, they negate the intended impact, so they have a negative notion, but they can also positive surprises. So the definition of rebound not necessarily must be a negative. An example of rebound effects could be that, again, thanks to the fact or due to the fact that we interact suboptimally, for example, in hybrid conferences, and we exchange research process less, then a rebound could be that the research progress is delayed or hindered, which means have a rebound effect on the I don't know, the progress of society at large. So it is again important to observe the impact on various sustainability aspects and the timeline to monitor that, so that we are able to detect rebounds and then also eventually plan for the corrections. A simple example that I always bring are applications that are in the healthcare domain that are created to make healthcare either more affordable, more accessible, or to increase the level of health of people. To my knowledge, very little is being done to monitor the actual effect of these applications to make sure that they really help achieving the intended effects, and if not, then they should be corrected. You are still with me? Okay.
Yeah, it's okay.
Said that, let's talk about software then. So when we talk about software sustainability, we can map these notions on the direct impact, and then we talk about sustainable software. And what I say is that we look inward at the system as such. And the traditional or lesser traditional quality requirements of quality attributes are, for instance, maintainability, that are near to the notion over time of how easily a piece of software is maintainable from a technical perspective, or changeable or adaptable. Or, for instance, energy efficiency, which lives in the environmental dimension of focus. So, and then we want to make the piece of software consuming less power and therefore less energy. Whereas outward looking is the enabling effect that we saw before. So the piece of software is expected, for instance, to be trusted. Think about your e-banking applications. We trust the application to securely handle our data and our privacy. Or, for instance, certain definitions of usability, of digital inclusiveness. So this is the indirect impact of software for some sustainability goals. Example that I always make is the software that is embedded in drones. So in this specific example, we can argue that the drone needs, so the software on the drone needs to be technically optimized in order to fit in the device, but also must be energy efficient from the environmental dimension of focus, because otherwise it drains the battery of the drone before the mission is completed and then the drone is falling. So this is about inward looking. At the same time, if we use, for instance, drones for healthcare, the drone can be shipped by bringing medicines, for instance, in areas that are difficult to reach in case of floods, emergencies, or simply bring healthcare to people that live in remote locations. And in this scenario, the use of drones for healthcare can make healthcare accessible to a larger chunk of the population, but also can make it more economically sustainable, so more affordable. Again, the extent to which this specific technology helps should be also measured, of course. In the timescales, we map the three order effects in what we call the immediate, enabling, and systemic. And what is important is when we design and implement for software systems that should be sustainable over time, then we have to make decisions or to reflect what are the concerns and the features of this software product that fall in the immediate impact or that fall in the other impacts. So one way of looking at this is that we define the scope of a certain software project or a certain configuration or version of the software product within the immediate impact. So the boundary of the project is what we call immediate. And then everything that is beyond the duration of the current project is outside. Still representing the aspects that fall outside will help sustainability over time, because if things change in the context in the future, then other elements that might be of influence could become more important, or maybe in another version they become immediate. So I bring an example here that I saw a couple of weeks ago. So it is around the cryptocurrencies. So there was an interesting news. I don't know if you heard about that. So one of the most well-known cryptocurrencies is Ethereum, and there was a big software patch of Ethereum that was called the merge that was claimed to reduce the energy consumption of Ethereum by 99.95%, which is a lot. The message of this news was, hey, this is fantastic, because cryptocurrencies are known to be extremely energy inefficient, so energy eager. And then by optimizing the energy consumption, then we can make them better. So that's great news. So in this case, we might argue that energy consumption is decreased thanks to this patch that basically changes the algorithms that is powering the cryptocurrency in this case. But I think the reflection point is the following, and here we talk about promises. So cryptocurrencies are promising to create new business opportunity and economic freedom to states that are too much regulated. My doubt is that, yes, there are entire data centers that are necessary to run cryptocurrencies, but is their energy footprint counterbalances the actual impact from a socioeconomic perspective of bringing freedom of new business model or freedom of economic freedom from everybody. Also, this news from the World Economic Forum was trying to give this message that cryptocurrencies are good because they bring this freedom. But then we should argue if by observing the impact of cryptocurrencies in different countries, if this actually promise is realized or not. So this goes in the direction of the order of impacts. We have many positives, many promises that we see today, and then we adopt technology or implement by adopting certain patterns. And then we have to ask ourselves if this promise is actually realized, and if not, we should have the guts actually to roll back and remove such technologies. A small, so to be able actually to define this stable level of sustainability quality that we are talking of over time, then the question is, we measure a lot of factors, a lot of effects, but how can we define the range in which we can claim that over time the total quality is actually sustainable in whatever dimension of focus it is? So this is a small, very initial idea that we shared in the context of software adaptation, and can be applied actually in any type of software, I think. So the fact that we have this network of effects that we can measure in any point in time, but then we have to define the boundaries within which variation is allowed or is advisable to happen. And then if we observe, so that like a min-max algorithm, and if we observe that over time we are starting to diverge, then we should apply the famous corrections. So if we would be able to define sustainability in terms of this chain of effect within this network, so this min-max, then we could have a more operational definition of sustainability, and then we could really observe the trend over time, and if we are going in the right direction towards a certain sustainability goal. I was talking last week with a guest lecturer from Signify. Signify is a spin-off of Philips here in the Netherlands. I think is one of the global leaders in smart lighting. And they were saying that they have to revise their own SDG priorities, because in the economic dimension, they already achieved the economic goals that they set themselves for 2025. And then I was thinking afterwards about that, this is actually not sustainable, because we cannot have a company that is always gaining more money forever. So, and then the question is, what makes, from economic perspective, a startup rather than a larger companies really sustainable? Then if you think about the cost versus revenues and proportional to the growth or the shrink of a company, then these type of models could help, I think. So the reflection point for this part is when we talk about sustainability, we can talk about sustainability only if we address both the dimensions of focus and the dimension of time scale. And it's not necessary for every type of software to address all 4 dimensions of focus, but it's really important that we ask ourselves, what is the priority for this software product? And then what does it mean in a time scale? Another reflection that is more related from the evolution of software architecture that we call more and more digital, because in a digital society, the separation between software and the rest of the world is becoming smaller and smaller, or fuzzier, is that we still tend to treat context at a second order of importance. So we design very much the systems, but we don't design explicitly the context in which we envisage such systems to be embedded. And this is not only the execution environment. For example, we can identify at least 3 types of contexts that are relevant. One is the evolution, thanks to the digital transformation, of the organizational one, in which we are not talking about information systems anymore within a company or an organization. We are talking about information systems across the digital communities. It's not only social networking platforms, but it's even the e-government and the public sector that is supporting, for instance, civil communities, civil rights communities, NGOs, representatives of target users, and so forth. So we don't have the boundaries of a company or a municipality anymore. We have really communities of individuals that are organized digitally. The second aspect, the type of domain, type of context is the domain. So when we talk about an application domain, we used to think in terms of partnerships. Think about, for instance, the automotive sector, in which when we build a car, typically tens and tens of different organizations are involved in the ecosystem and all contribute their own community components to an individual car. So now we are not talking about partnerships anymore. So we have really a combination of different sectors. To give you an idea, for example, many countries, the government, which used to have only the goal to support, for instance, the citizen, nowadays, thanks to the digital transformation, they are turning into digital service providers for other sectors, like, for instance, for traffic management, or the other way around. Google Maps are helping municipalities to manage the traffic and the investments in the infrastructure better. And this is tiny examples. If you think about that, there are, over the decades, many organizations that changed their own share of the market thanks to this digital transformation. Google is invested in cars. Yeah, this type of examples. And the last is about the notion of business. And this is maybe one of the most challenging in my perception of organization, in which business used to be led by economic revenues, and more is asked to be led by ecological footprint. The organization can perceive the role of software in this transformation either as motivating or tuning the current business model to be digital or to be less polluting, for example, or the most innovative aspect is really to think about new business models. This is maybe more challenging, but the reward can be bigger. Or the other way around, there are many more organizations that are popping up everywhere, new startups, new innovators, that can tomorrow actually steal your chunk of the market if you are not innovative enough, or organizations are not innovative enough. So the question is, when we design, for instance, for software architecture, how do we design for the different types of context? Do we consider that? That's important in order to be able, again, to assess the impact of software in a sustainable sustainable dimension. Here I have examples from the news for this type of context. So we have in the Netherlands Van de Bron, which is an energy distributor. So basically they had the challenge to create a digital platforms for any organization and citizen to share their assets, like, for instance, the battery of your electric car. And the intention was that individuals could actually decrease their energy bill, which is a big problem at the moment. But also, thanks to the local consumption of energy, the total grid could shave the peak of energy consumption, which is the old design of the grids, which is the major problem in order to be able actually to balance better the energy use, the energy market. So the combination of software and, well, the IT industry and the energy industry here is very important. And here you see that the challenge they had was not to create an portable or interoperable platform. The real issue was to create trust in the target users so that they would actually be able to share their assets in the first place. So the second reflection is in the global change of basically the digital workforce, in which we have this massive migration out of the boundaries of office space and more and more flexible work from home or from other hybrid locations. And then we decide just in time when and where we want to work from or study from. So then this dynamic change that we have to embed in the systems in order to support these just-in-time decisions is a big challenge that we never faced before, I think, in software engineering. So what are there any patterns or tactics that support for this type of fluidity? And what does it mean, dynamic change embedded in systems? It's not the definition of self-adaptive systems is not good enough. We should cope not only for different scenarios of change, but also for scenarios that we didn't envisage yet. And last but not least, many years ago already, we were talking about the digital revolution, which means basically how digital influences the planet. And so I think the question remains nowadays. So what is the knowledge that allows us in software engineering to support this promise? How can we support integration, effective integration of sustainability, or how we model for innovation? So I hope that this was not boring. So in this context, so over the year, we tried to build some tools, so what we call instruments for software assessment. So it's also for software design and assessments, they go hand in hand. So how do we support software engineers and IT professional decision makers to make such informed decisions for sustainability? So this is open source. You have the link here in the bottom. You can download it, use it, reuse it, change. So essentially, there are two tools that are produced by this toolkit. On the left-hand side, you have the decision maps, are very simple views or diagrams that allow us to frame for the project what are the sustainability quality concerns or the design concerns that we should take into account. You can think, for instance, in requirements engineering, this might be the requirements. In software design, they are the design, the target quality. And what are the dependencies among them over the three different order of effects? So in the timeline. And the second output of using this toolkit is what we call the sustainability quality model. It's basically, you can see that as a knowledge base in which we collect the definitions in the of quality concerns or quality attributes in the 4 dimensions of focus. And we collect a database of metrics and measures so that we know over time, possibly better and better, if, for instance, a certain software design patterns has a positive or negative effect on energy consumption. And how can we measure that? And then by reusing more and more the same pattern, maybe we have a number of metrics that could be selected among, and then we know that this pattern is bringing so much on average energy efficiency. On the right-hand side are other instruments that allow to build the decision maps and the quality models. I will explain these elements to give you an idea about the use by using an example. So here you have a decision map of a very simplified model of the notion of on-site conference. So in the center, you see the project is about technologies that support on-site conferences like this one. And then there are two features that could be influential if we target, for instance, the carbon footprint of conferences. One feature is the travel, the physical travel, and the other one is the potential ICT infrastructure that we have to put into place, for instance, to support paper presentations or other things, or digital communication. And then with this simple notation, we have in the boxes these sustainability quality concerns. So we care about the carbon footprint, and then we know that a travel has a potential negative effect on our carbon footprint. At the same time, the green arrow shows that the expectation is that by traveling physically to the conference, the knowledge transfer is positively influences. So I can exchange ideas more freely, and then I can transfer my knowledge better. At the same time, the ICT infrastructure has an undecided effect on both. So I don't know how much infrastructure I need in order to support the knowledge transfer or the conference. And I don't know how much infrastructure I need, well, I have to put in place, and therefore the related carbon footprint. I will know once I put in place a configuration of a conference, and then I can measure that. So this is, we see that in the immediate order of effects, I put in place two features that enable lowering or increasing the carbon footprint and having a certain effect. And then we know that conferences cost, so there is a certain impact on the level of cost. In turn, the knowledge transfer is supposed, if it happens to different degrees, is expected to have a positive effect on the systemically on the impact of our research. So this is the result of assessing the practice of a number of conferences in our field. When we represent these elements in a diagram, let me find my mouse eventually. Here we see two copies for, on the right-hand side, what if we compare this with virtual conferences, fully virtual? Then we see that we have a different type of trade-off for travel and ICT infrastructure, because we don't travel anymore. So that has a positive effect on the carbon footprint, and the other way around. Our experience is that the knowledge transfer, unless we really design carefully, it's anyway negatively impacted by not traveling. At the same time, we need to have a much more powerful ICT infrastructure in order to support the whole conference rather than only a paper presentation. So overall, the expectation is that the knowledge transfer is less, and there is a negative impact on the research. So if we put these things together, so we can make more informed decision about where we want to invest and what do we need to measure in order to see what we want to achieve. Once we define basically for each of these boxes, so the quality concerns, a definition, then we can put in our quality model. And here we see that on the bottom, so it is really important that we trace definitions that are refined over time within the organization or for a certain application domain or sector. And here we trace over time the source of the definition and revision. And then we classify according to the 4 dimensions of focus. And eventually we collect the metrics or KPI that we use to measure each quality concern. This is a quality model that we started from the ISO IEC 25010 on system quality, and then over the years we classified and extended for sustainability. But the real challenge difference between normal software quality models is that, first of all, the definition of software sustainability quality concerns must be sharp in order to identify if the definition pertains one or multiple dimensions of focus. Because, for example, by looking at the standard, the 25/10 standard, which historically were more focused on technical and maybe a little bit economic, sometimes the definition, for instance, if you think about work effectiveness or resource efficiency, it is not clear if resource efficiency is about computing resources like CPU or networking, or if we are talking about energy as a resource. And then depending on how you define, can be either technical or environmental. So by being very clear about the definition, we can also better classify for sustainability. At the same time, a difference is that we may have, for instance, like in the case of resource efficiency, the same quality attribute that is defined multiple times, but in different dimensions, which is also possible. So once we have this, we can translate our ultimate sustainability goal into what are the factors of influence that we want to measure. For instance, in resource efficiency, are we measuring in terms of the performance versus the energy consumption? So we basically operationally translate every goal into factors, which is basically mapped onto critical questions, each regarding a quality concern. And then for each quality concern, we want to measure the actual effects of the factors towards the goal, which means we measure each concern with metrics. And then in the end, we have an algorithm that computes the minimum maximum level within this famous min max that we mentioned before, so that we can observe the variation over time or the trend towards the sustainability goal. And this is what we did, for instance, for the famous conference of before. So the area of these spider charts is sustainability, is the degree of sustainability that each model of a conference is promising to bring. And not surprisingly, we see that, for instance, on-site conferences are measured to be much better in the social dimensions, thanks to the knowledge transfer in a physical setting. But whereas the virtual ones are much better in decreasing our carbon footprint, but not so good for the social aspect. And not surprising, if we have blended or hybrid events, then we should invest in balancing the environmental and social with eventual positive effects on the overall economics of the conferences themselves. So you can imagine that if you could use these models, for example, as a sustainability model for your software product, in this case, the software infrastructure we have to use for a conference, then we can design better for what we want to achieve with that. Do you still hear me well? Okay, because
sure.
I got a word of the network.
Sure.
So the reflection point is that we have to look at holistically of the trend over time. And I think that 10 years ago in software engineering, we were very much concerned about the precision of the measures. And then we were facing this intrinsic complexity of software intensive systems in which we have so many variables, like, for instance, the type of technology, the type of infrastructure, the specific algorithm used, etc., etc., etc. And instead, what we should maybe focus is for types of systems, the general trend. And then by observing the trend, for instance, same type of systems in different configuration of the evolution of a system, whatever configuration it has, then we can make better decision for the overall sustainability. Finally, I would like to maybe pitch a couple of ideas about the case. So in a cloud-based society, so the cloud-based software. This is a very old slide, 2015. And then I was looking back to these, and that was very ambitious. At the time, there was studies that showed that the prediction was that the majority of enterprises and companies would migrate towards the cloud. So nowadays, we look at both private and public markets, and on average, 90% of the organizations are cloud-based. So this happened, but the promise of optimizing the level of bloating of the software is not realized at all, I think. And also the ambition to create labels for software that would actually help consumers, customers, and individuals to choose better depending on, for instance, green labeling, like we use to buy a TV or a washing machine, is not there yet. So I think all these challenges remain greatly nowadays. There are new energy, new organizations that are working in this direction. However, there is a lot of research to be done here. And I think we must be mindful about creating metrics that in the past helped practice to show or that they were doing something good in terms of sustainability, but basically misusing this measure for the economic gain rather than really investing in sustainability itself. So metrics are necessary, but I think we as researchers, we should create metrics that cannot or are more difficult to be misused for window dressing. So for the energy consumption of software specifically, this is one of the biggest issue, I think, for a cloud-based society. And the issue is a little bit represented in this projection and the one before, afterwards. So here we see that there are two major trends that in the energy forecast. One is the increase in energy consumption of data centers themselves. Recent figures show for many data centers that in spite of the services of the amount of data that they manage, they are more or less stable in terms of their own footprint. Not necessarily this is a good thing, because I can feed my data center with wind energy, for instance, and then claim that I'm carbon neutral. Still, maybe my data center is not doing anything useful. So this is not energy efficient and definitely not carbon neutral. Of course, I'm exaggerating. But this is a reflection point. In the same vein, the blue area shows that a major impact is due to the network traffic thanks to mobile devices. And mobile devices include mobile phones, but also our laptop computers, for example, of the famous drones that we saw before. So the network traffic has been badly neglected, like it was negligible. But nowadays we are building more and more hyperscalers, data centers farther away, which means that we need more powerful infrastructure to connect, for instance, the cities or our mobile devices with the data centers that provide the cloud services and our data. And this has exponential effect on the energy footprint of the whole complete distributed systems. So, for instance, in the Netherlands, there is a massive migration back from the remote cloud to the edge. So-called micro clouds that are promising to bring the interactions nearer to the user or the consumer, so the client side of the software. And I think this is a very interesting model, architectural model, because then, especially with the massive use of artificial intelligence and machine learning in any type of sectors, we need a lot of interactions with the data. And then if we have less data traffic, that is definitely advisable. So many reports that discuss the improvements towards sustainability of data center talk about performance, but they never talk about degrowth. For instance, reducing data traffic, reducing the amount of data that is stored and never used. This is an example of this misleading information, I think. On the left-hand side was used by a colleague of mine, an expert in machine learning, a few weeks ago. So this is an information about the amount of data that we produce only for the healthcare sector. So there are a lot of machine learning algorithms that basically are better or less fitting for certain applications. And once they basically in training the models, they achieve a certain level of knowledge, then whatever amount of additional data you feed them is useless because the change is negligible to zero. So, which means that different algorithms can achieve convergence to the max learning, and then by observing, measuring the conversion to this max learning, then we can basically remove all the data that we don't have to collect more data. In the same vein, on the right-hand side, there was a study about the carbon footprint of AI algorithm based on where we run the training. So if in specifically where the data centers are located. And you see, depending on the energy mix that the data center has, you have a certain level of carbon footprint that can be different. But the real question is, can we actually avoid to move all the data to the remote cloud, so train the data more nearby, so that then we can only store remotely the result, which is the model, and then use the model. Last example is a study that we did for a cloud provider, again here in the Netherlands, that is helping their customers in migrating their software applications partially to the cloud. On the right and left-hand side, we collected a number of software tactics that are available from the literature, and then we did an experiment only with one, applying edge computing to an application that was using, again, machine learning. And on the right-hand side, you see that we had two A/B testing, two scenarios, one in which the basically, I don't find my mouse again, but in the lower part, you see the scenario in which all the data are transferred to the cloud, and then the training happens there. And in the upper part, you have this scenario in which you have at the edge where you collect the data, you have the training, and then you just transfer the results. And the difference is staggering. I'm not saying that this is technically sustainable. So probably when we start optimizing, then also there we converge to a certain level. But because the software is so bloated, starting to create new ways in which we design software intensive systems can have a non-negligible effect. So my statement is that data centers that host our software and our data, they not only they have themselves to be energy efficient and be fed by the renewable energy resources, but especially the software that we run in the data center or that we use from the data center should be optimized, both from the architectural perspective, but also at the level, or at all levels, also at the use, for instance, of the specific algorithms or specific libraries, for example. I don't know if I have still time, but I would like to go actually to the conclusion. So what is my reflection on the role of sustainability for software engineering? What we saw is, one, we historically never or hardly considered the context. We consider more the system, and the role of context is becoming more and more important naturally because software is everywhere. So we should change the type of models we draw, in which we model the context explicitly in relation to the software system. Complexity is also ever increasing, so we must be able to control or trace our systems of systems better. We are, I think, still unprepared for true flexibility. We assume a lot about the power of software in our society to deliver flexibly anything that we need just in time, but designing for this flexibility is less. And also making and growing these knowledge bases about the sustainability quality attributes is important, both to be able to measure and make informed decisions, but also because quality attributes or quality requirements for sustainability have a different nature. They are more about intrinsic values of society, like the right to be forgotten in GDPR, or digital inclusion for our society than they used to be before. And naturally so, because we are more and more supported by software systems. So when we think about sustainability, again, we think in terms of benefits. So they should address, software should address it, but we have to plan for it. So to go back, I think we have a responsibility, also in the small, to reflect regularly about what is our role as researchers and how, as software engineering researchers or practitioners, we contribute to the bigger picture, and what are the values that we can translate into quality attributes of our software products. And this is what I wanted to share.
Okay, thank you very much, Patricia. It's a very, very great presentation, great talk. Thank you very much. Particular for me, I like this talk today. I would like to thank you very much again. I will invite everyone that can open the camera to talk with Patricia, please. Yeah, then I would like to open the words for the audience. Please feel free for questions to Patricia.
Lisa, may I start?
Yeah, please.
Thank you for your talk, Patricia. Very interesting and very important topic for our society as a whole, right? And I would have a question about the sustainability assessment framework specifically. I saw, especially because we are organizing a conference and we are in that point of decision, we have already decided as community that next year we will take on-site conference, and people are willing for that, right? But actually, when you showed those maps showing the trade-offs between the alternatives, for example, on site we have a higher cost and virtual, we have lower cost. And then you found a solution where hybrid, for example, would be the best of the worlds. And actually, my question is how people use, in your experience with that framework, how people use that to even understand and the problem as a whole. And maybe we could have, for example, another alternatives emerging for that analysis. Do you see that this happens? For example, we could think, for example, instead of hybrid, could we think of 1 year on site and 1 year virtual? So, and someone could think on another alternatives. How do you think of that could work when people take decisions and think about that we use in that framework? Thank you.
Yeah, that's a very good question. So, as you know, in the community, we have regularly this type of options that we explore. For instance, one's virtual, one's physical. I think, first of all, one of the major impediments are human beings, because my personal view, maybe well, I don't have so much experience, but is that when you have to choose, you are general chair and you have to choose if you are the one that is doing virtual this year, nobody wants to do that. Everybody wants to host physical conference for different reasons. So, and that could be a model in which basically the intent there is that you mitigate suboptimal knowledge exchange, if any, with 1 year of physical conference in which you have a better situation. But I think it is possible actually to have a blended conference every year in which, for example, we have to think about which components in the features of the conference should be designed for improving actually the knowledge exchange. There are nowadays a lot of smaller events, like smaller workshops. I attended one a couple of weeks ago. They are fantastic for knowledge exchange and they are blended. So we are not so experienced in designing different types of interactions. To give you an example, we are still very much geared around the paper presentation. I think we should drop it. The small pitches that attract you to read a paper, I think are more than enough. But the real idea is, why don't we gear the whole conference about the old model, effective model of discussions and working together and thinking about creating a community, for instance, a working group that then is doing research together, a project proposal, or writing a paper out of the research. So I think there are many different possibilities that are better for blending, and at the same time, I mean, can get both a lower carbon footprint and effectiveness. And the other aspect, for instance, about the carbon footprint, we are looking at how we can attract researchers, everybody, to think more mindfully which conferences are really helping me in my progress. And then I don't travel, maybe I travel less, but when I travel is an added value. So we developed ourselves in the idea of we like traveling, but in the modern world, it's not a good idea anymore. And then when we do that, we should target the real venues in which we meet our community. So there are these things, maybe a little bit extreme, I don't know, but maybe people don't like me that much, but I think it's possible. So these, back to the decision maps, they are simple enough to when you have the measure to think, okay, this feature, how can I link this feature to actually a certain structure? And if this feature is a feature of a piece of code, of a software product, then we have to link to software models, which, by the way, is a very big open research question, because as we know, the structure and the behavior of a software product or a software systems is cross-cutting its quality. So, and then the big research question is, how do we model this interaction of qualities for sustainability, and we link them to the structure and the behavior of the software product. And these are basically 3 different types of views that should be linked together.
Okay, thank you, Patricia, for your answer. Leila has a question here. Leila, would you like to open your camera and the microphone to elaborate your question, or do you prefer I read it? I think it's here. Leila, you have 2 questions? Are you there?
Oi, você pode perguntar, por gentileza?
Okay, yeah. And Leila said, thank you, Patricia. In your opinion, how is the awareness level of software engineers or companies to build sustainable software? This is the first question.
Mm-hmm.
Yeah, this is my question too. It's the same question. How it's possible to convince the companies to develop sustainable software in general, or this is initiative only big companies, for instance? Mm-hmm. What's your opinion?
There are different types of companies, of course. There are those that are seeing the opportunity, or maybe they really have the belief, so they value sustainability, but they are building their model on exactly this. For instance, companies that are building software development environments that at design time already, they give you the feedback when you interpret or compile a certain piece of code, what is the estimated impact on energy consumption. There are a couple of companies here in Europe that already do that. Of course, they need many more experimentation in order to build this type of estimates so that you can reuse them. Then there are also companies, independently from how big they are, that are waiting for the others. So they are more traditional, more conservative. But there are also large companies that are really moving fast. So they are investing a lot. We work with a major bank here in the Netherlands. They have a huge program, a sustainability program internally, which goes from making more energy efficient. They have over a portfolio of 4,000 applications, but also they are building KPIs and a measurements framework internally to monitor also their use of the cloud. And also there are major cloud providers, hyperscalers. Some are not doing anything and still investing in the window dressing, or I feed the data center with solar and wind energy. But there are others that are preparing simply because the governments are moving fast. So they are both, for instance, the European Commission is imposing caps and targets. And also member companies, for instance, in Europe, they are asking every year any type of companies or public sector, so the ministry, to report on their energy consumption or what they do for sustainability, also for their IT systems. So this is coming, and some companies are already preparing for that, and some others are working. But it's a very exciting era, I think, because I think it's good that thanks to also, if you wish, the pandemic, the end users, so everybody is aware of software finally. Before it was not so evident, and bottom up, so that the question will come from the users, and top down, the governments are pushing. So, and then suppliers and consumers, they will have to report, and then they ask each other, well, if I have to report, then you have also to perform.
Yeah. Okay. Thanks for your answer, Patricia. There is another comment from Leila. She said the research community about say about energy efficiency as a non-functional requirement. Some researchers agree and the others not. What's your opinion?
I agree, actually. So our complete work is in defining sustainability, therefore also energy efficiency as a non-functional requirement or quality requirement. So I think this is a way, I think most handy way to actually approach the problem.
Yeah. Okay. Yeah. Emmanuel, please, would you open your camera? It's possible? No? He said...
Hi.
Yeah, please.
Good morning, everyone. Good morning, Patricia. Thank you so much for your research. I would like to ask if you believe that your research can touch the sustainable development goals of UNICEF. I'm sorry, it's not UNESCO, it's UNICEF. If you believe, what goals you believe that you are more close?
In our research, you mean, or? Well, well, as a research community, the 17 I think is a good match because it's about partnerships and collaboration. So we invest, I don't remember by heart the names, but we invest in two. One is related to climate. I believe it's the number 5, but I never remember. And one is number 12, if I remember correctly, which is about responsible resource production and consumption. So it's easy to map on I think 9, which is about industry. But I think that going back also to Leila's questions about energy and energy efficient software, it boils down to responsible resource consumption, I think, and production. Why? Because we invested for many decades in software engineering in using carelessly devices or hardware that was not expensive anymore, or resources that were not expensive anymore. And we invested in making software understandable or programmable by anybody. And in doing so, we created the bloated software. So now we have to optimize back to consume less. So this is yeah, this is I think the best fit. My criticism, which if it is not really a criticism for the SDGs, is that well, they have been created to be digestible and approachable for many different sectors. As such, they are very broad. So each SDG, I mean, they together, I think they define like 160 something different indicators. And you can use the indicator in many different ways. So this is very, going back to the initial discussion, can be used well, but can be also misused.
Okay, thank you so much, Patricia. It's a pleasure to see that you think about these goals. Thank you so much.
Yeah, thank you.
Okay, next question. We have a couple of minutes here. Yeah. I have so many questions here, Patricia. I will use the side of the
I think we have time also.
Yeah. do you think it's possible to find a formula to calculate sustainability, or this is case by case? It's very hard to manage sustainability because we have different contexts, different things that we need to consider to do. This is a sustainable software, or this is not a sustainable software. Is it possible to have this formula, or?
So we have a general reference. So when I was going, I don't know if I can actually, you don't see my screen anymore?
No, the screen.
Okay. I'm looking there. Let me just share again in I think it's this one. So I have to see if, yeah, here. So when you have this mapping, it was a little bit quick, but the point is that this is a general approach in which for each quality concern, when you can measure that, but then the formula is to define the goal in terms of minimum, maximum, or balanced level of a certain quality. So
it's not possible to have a unique formula considering each quality attribute. This is a...
Yes. So the unique formula goes in the direction of the labels that we mentioned before. That exist. So for instance, there is the PUE, that is a KPI, a formula that has been created for data centers. And nowadays, the reorganization like SDIA, the Sustainable Digital Infrastructure Alliance, which is defining the equivalent formula for software, or the software carbon efficiency, if I remember correctly. So they are working in that direction. But again, the PUE, for example, was a great idea to move the sector, but then it was misused to make the data center efficient, but not the content of the data center. And then for the software, these indicators, these formulas are then parametric in terms of what is the unit of measures for the software. For banking is the business transaction that it supports. For, I don't know, healthcare is, I don't know, the frequency of monitoring a certain factors. It can I think it can be only, you have a general formulas, but then you have to specialize case by case. We, in the same vein, we have different labels for TVs, different from the washing machine. I don't think it's such a crazy idea to have different labels also for different categories of software.
Okay. Then in this way, do you think it's easy to include sustainability as a quality attribute in the ISO, the quality?
Absolutely. Yes. So the ISO, in fact, wanted already over 5 years ago. Actually, they were very interested to add software energy efficiency as a label, as a standard. But in the end, we arrived to the conclusion that it was too early to be able to standardize that. Now I think we have much more knowledge and we can work in that direction. Yes.
There are many different studies about the definition of sustainability today. This is the first step to define what exactly is sustainability in software, and after that you think to include this sustainability in the ISO, for instance, or standardize.
Maybe I'm mistaken, but I think that especially the Brazilian society is very knowledgeable about software engineering experimentation, for example. I think massive experimentation is necessary in order to build this evidence so that we can start building these labels.
Yes. Christina, would you like to do some words or some questions? You open your camera.
Okay. Now I can say thank you for your talk. Patricia. And I put a question in the chat about the sustainability of the model, the sustainable, the SAF model framework and toolkit, the context of so many changes, evolution in society and technology and different contexts since software is everywhere.
So the question is about how sustainable the toolkit itself is?
Yeah, about the model, how do you evolve or invalidate these resources?
That's a good question. So the models themselves, so it's informal visual. So we don't apply any, for instance, model-driven techniques, if this is what you're thinking of. It has evolved over time a lot. So I think this version is the result of 5-6 years of research. You wouldn't imagine that because it's very simple, but it's simple by design. What I hope is that by sharing the toolkit as open source, also the community will take over and change it towards improvements. I don't know if this answers your question, but in the same vein, for instance, the quality model with the definitions and the metrics, etc. This is the version 2, and everything is shared on GitHub. So I hope that if better idea come up, then these also new branches will be created and pull requests.
Okay, thank you.
Okay. Patricia, going to the finishing our talk. Yeah. Oh, it's the time's fly. Yeah. And last question: if there are so many students here, if you want to say some message for these students, which is the next urgent step in this area for all students in different areas? Because I think sustainability is related to requirement engineering, architecture, or every topic in the software architecture or software engineering area. Which is your main message for these students?
So, well, this is one initiative that we launched recently, also open source. So we share this open catalog of tactics, and this can be software patterns or anything. So I think a major impact that we can have is when we have even tiny results, which is a measure or a pattern or a good practice or an anti-pattern, then to share it openly. I think this is the direction. I think from a specific research area of software engineering, my lessons learned is that the sustainability is very broad, is to make the context of your research smaller and try in the smaller context to have an impact. So for example, a great area is energy efficient software, can be at a design level, can be at the code level, and then take a specific playground. Like for instance, we are trying to start a smaller project on measuring the energy consumption of JavaScript, in fact, libraries. So we adopt a lot of libraries when we develop software. So if we measure the impact of a library rather than another, so then we can start labeling these libraries. So this is a very small thing. So even if only zooming into the energy consumption and then starting providing this empirical evidence, that would be a great result, and building upon that. I, of course, work in software architecture, so linking together, as I said before, the qualities with new architectural views and viewpoints, that is my personal passion. I think there is basically nothing at the moment in that direction.
Okay, Patricia, thank you very much for your talk. And thank you very much for sharing your knowledge about this very hot topic here in the area of software architecture and software engineering. Then I would like to say thank you again. Then,
Thank you for having me.
yeah, and open your cameras. Only to say thank you very much.
Thank you.